example number 1, graph the inequality x minus 3y is greater than 6. So first things first, what we want to do is we want to actually graph that line. So what we have to do is we have to make this, instead of an inequality, we have to make it a line. So x minus 3y equals 6. This is in what? General form. That's right, not slope-intercept, because the y is not all by its lonesome. So what I need to do first is figure out what my x and y intercepts are. X-intercept y equals 0. X minus 3 times 0 equals 6. X equals 6. To find my y-intercept, x equals 0, so I'm going to substitute x as 0. 0 minus 3y equals 6. Negative 3y equals 6. Y equals negative 2. Now what I want to do is I want to graph that line, keeping in mind, what kind of sign is this? If it is a greater than or equal to, if it has that extra little line, it means that the solution region includes that line. So I have to make it solid. Since it's not included in the solution region, I'm going to denote it with a dotted line. So I'm going to make my, I'm going to do my little sketch. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And I'm just going to label my scale 1 and 1. I know that my x-intercept is positive 6. And I know that my y-intercept is negative 2. 1, 2. So I'm going to fill in that line, but do a dotted line. When we're asking for a specific solution region, what we're actually asking is, when I plug in a coordinate, so say something like negative 3, 2, is this inequality, does that hold true? What happens if I put something below the line? Say something like 1, negative 3. Is that going to hold true? So what I need to do is I need to set up a test point. Guess what, guys? We're not going to make this hard. We're going to make this as easy as possible. Your test point is always going to be 0, 0. If I put in 0, 0, and this inequality remains true, then I know that solutions include 0, 0, so that means it's above the line. If it does not hold true, it means that solutions are below the line. So the solution area is below the line, so that's what we'll shade in. So let's use our test point. And just for ease, it's always going to be 0, 0. So this looks pretty familiar. It's kind of like verifying that we did before. Left-hand side, we're saying 0, because I'm plugging in 0 for x. 0 minus 3 times 0, well, that's just 0. Okay, so what's the right-hand side? The right-hand side is equal to 6. So it says right here, if the left-hand side is 0, 0 is greater than 6. What? This is not true. So the solution region does not include that test point 0, 0. So that means that the solution area is down here. So this is what I'm going to shade in. So that means if I would put in anything above the line, any point, so negative 3, 2, it wouldn't make this inequality true. I just want to prove my point by putting this point right here, so 1, negative 3 in here. So this is just an additional point. This is just for me to show you. You don't have to do that. If I ask you to do a question like this, this is just for me to show you. So we're saying test point 1 comma negative 3. So we're going to say left-hand side equals 1 minus 3 times negative 3. 1 plus 9 is 10. The right-hand side equals 6. Is 10 greater than 6? Yeah, 10 is greater than 6. True. If I can remember how to spell true. True! Okay? So it means that this shaded region is where this inequality holds true. So like I said, guys, if I plug in any coordinate point that is below the line, this is going to hold true. If I plug in any coordinate point that's above the line, the inequality will not hold true. So wherever it holds true is the solution region.